Welcome back.
Welcome back, guys. Happy to be there.
Yeah, the last part of the day, an introduction to WebGL, 3D, and Babylon.js with David. So let's go. I'm still Eric, you know.
Yeah, and I'm still David. For those who didn't know me, I'm program manager for Microsoft DX, Developer Experience, and I'm more focused around Open Web Standard and IE. But today, and for this specific session, I'm here because I am the author, the father of...
the father.
Yeah, father, yeah, that's exactly the term. It's my baby. Yeah. And of a free open source framework called Babylon.js that I will present soon.
Okay, so the agenda for this last session is 1, using 3D accelerated graphics with HTML5 and of course WebGL.
Yes.
Using Babylon to get right on WebGL complexity.
Yep.
And performance consideration, because it's something really important.
Yeah, it's about cross-platform. So we have to deal with different quality of hardware from low end to high end. So we will have to discuss a bit at the end. It will be perhaps a little bit complex, but we have to discuss that.
Yeah, but it's still a very interesting subject to know.
I think so.
Yeah. Okay. So, 3D accelerated graphics with HTML5 and WebGL across devices, that make a lot of sense to invite you and to finish the day with that.
Thank you.
Cross-platform, it's about HTML5 all the day. And yes, HTML5 is live today. Okay, so what is WebGL?
Yeah, it's a good question. What's WebGL?
Yes, a good question. So it's a JavaScript API.
Yes.
So that makes sense to have it today. It's based on OpenGL Embedded System 2.0.
Yes.
It's standardized by Cron's Group, and it works perfectly well in Cordova, as I demonstrated this morning.
Yeah, you did a blog about that using Babylon.js into a Cordova application that works pretty well.
Oh yeah, that was pretty well on Windows Phone, on Android, on the Firefox OS I just tested last week, and of course iOS.
Yeah, since iOS 8, WebGL is now almost on all modern, let's say, small devices.
Yeah. So that makes sense to have this discussion about WebGL now. Using WebGL directly, it's possible, of course, everything is possible, but you have to handle everything except the rendering. So you have to manage a render loop, handle the texture and all the resource management, create the geometry, topology, and of course, create shader code, and sometimes shader code is not so easy. Yeah?
Because when we want to deal with this kind of low-level API, you have to be good at math, you have to be good at GLSL, which is the language used by the shaders. Yeah. You have to perfectly understand how the GPU and the CPU are communicating, how the memory bandwidth is used, and that's not easy. It's really, really low level. Yeah. It's like wanting to create your own car, but just based on some trash of metal. You have a bit of metal, you have a bit of gas, and you have to create your car.
Yeah, not so easy.
Yeah, that's not easy.
Yeah. That's why perhaps we can see a demo about that.
I think I can show you how WebGL is working if you want. Okay, so I prepared for you guys a small project that will be available, obviously, with this course at the end. It's something I try to do the simplest WebGL code possible.
Something like a box?
Yeah, not even a box. I just tried with a triangle.
Okay. So
basically, what we need from the point of view of HTML5 is just a canvas.
Yep.
WebGL is rendered into a canvas, like we did with, for instance, if you are dealing with 2D. WebGL is rendered into a canvas. I also use a specific JavaScript library called GL Matrix. This library will get me right off using all the math implied into computing matrices and etc. Okay. This is not what I want to show you today, but it's an important point. You have to deal with math if you want to work with WebGL.
Matricial.
Matricial computation with vector 3 and things like that. Yeah. That's not easy, it could be far
from you, man.
Yeah. The very first step we have to deal with is pretty simple. You just have to get the canvas itself, define the rendering size you want, and you get a new context. Instead of getting a 2D context, this time you will get what we call the WebGL context. Here, it's experimental. You can ask for experimental. It's like prefixes when you are working with CSS. It's a way the browser vendor used to tell you that it's not finished, it's not final version of WebGL.
Okay.
So I get a context, I'm calling it GL here. The second step, because we have to deal with two different processors here, this code, the JavaScript, will be executed on the CPU.
CPU, yes.
But WebGL is about sending order to GPU. So we have to send code, we have to compile something for the GPU. And if we go back to my page here, I'm using a little trick. I have two scripts here, but these scripts into my web page are not about JavaScript, it's what we call GLSL.
Okay.
Graphic Library Shader Language. The very first one is
the main
vertex shader, and the second one is pixel shader. I don't want to go too deep into this specific stuff. If you want, guys, to have some MVA course about really how 3D is working on the web, just use the chat for that, and we can think about creating a specific MVA course for you. Here, we can just imagine that this specific code will be, it's like C for the GPU, will be compiled in a way and sent to the GPU. So I just write my code here because I need space to write my code. So I have here a small function that will get this code from the DOM. Pretty simple. I just go through a specific element and at the end, I'm using a specific function of GL, which is create shader. Please create a shader for me. This means compile this specific code into some assembly for the GPU.
At this time, it's dynamic compiling.
It's dynamic, absolutely. It's about dynamic compilation, exactly. Okay. Then once I get my shader source, I can compile it, and if everything is okay, I won't have an error. Okay, this specific line is more for me in order to get some feedback. Oh, your shader is not working because you forgot something. Okay.
Okay.
Then I can get two shaders, the pixel shader and the vertex shader, and I have to link them, like in C. I will link my code to generate the final bytecode used by the GPU itself. So it's about attaching shader and at the end linking program, and this program is the code that will be executed by the GPU to render my scene.
Okay, the name of the function here is really clear. It's linking.
It's about linking. Yeah. We have OBJ like in C or C++, and I will link this code into the final output.
Okay.
Okay, and I say to WebGL, please use this specific program. Then I have to define my geometry. So it's about creating what we call attribute, vertex attribute. And I'm saying that this specific object will have position, color, and normal. I don't want to spend too many time in this specific stuff. It's really...
Just a question. You sure it's only for a triangle, that?
Yeah, for now we are just dealing about a triangle. Yeah, absolutely.
Okay.
Then I also have to define specific variable called uniform. If you are looking at my code here, I have two uniform defined. A uniform is a variable defined by the CPU and used by the GPU. Okay.
Okay.
I want to make my triangle rotating. That's why I need some specific matrices, and that's not simple. Once everything is defined, I have to fill my geometry vertex buffer and index buffer with some data. So here are the indices I want to send. So X, Y, Z, X, Y, Z, X, Y, Z. So I have 3 points.
One triangle.
This point will have, so first coordinate, second coordinate, third coordinate. First color, the color of the first point, the color of the second point, the color of the third point. And normals. Normals, it's something we need for light computation. I don't need specifically that here right now, but it's just to show you. So right now, somewhere in the GPU memory, I have what we call a buffer, and this buffer was filled with some data, okay? And then I have the render loop. The render loop will be executed as fast as possible. I clear the screen. I define some funky matrix here. Don't want to get into that right now. I define where are my vertex, and then I call one order. Please draw me a triangle.
Wow.
Wow. And if I execute that...
That's wrong.
That works. I have a triangle. So obviously, if you want to create a game, it will be a bit touchy.
Yes, that's the beginning.
Yes, that's why I can go back to the slide.
Yeah. I will back.
Oh, you have okay,
Yeah.
on your screen? On
Yeah.
Eric's screen?
And that's why, thanks, David, we have Babylon.
Yes, we need something easier.
Yeah, sure. So, what is Babylon?
Babylon is like the car. You want the car. You
Yeah.
want to drive a car. You don't want to build your car.
Okay, so it's 40,000 plus line of code.
Yeah, it's a big bunch of code. Right now, when you want to use a minified version of the library, it's around 500K, which is okay because it's not the size really doesn't matter here, because when you want to deal with scene, a scene can be more than 50 megabytes, so it's not the size of the engine itself.
Okay, so for this quantity of code produced in something like 2 years, less than 2 years.
Less than 2 years, yeah. I think the engine is like 1 year and 2 months old or things like that.
I think it's a huge team working on it.
No, we are almost 2.
Yes.
I'm the main developer, to be honest with you. I'm working with David Rousset from France, who helps me on some specific stuff, and obviously with Michel Rousseau, also from France. As you perhaps you didn't notice that, but we are French. And Michel Rousseau is the designer working with us to create the scene. I will show you right after, because when we work with 3D, it's not just about 3D shapes. It's also about creating really appealing scenes, and that's why we need a designer, and that's important.
Yep.
The site is is getting a lot of traction right now.
Yeah.
People like Farmers Insurance, Ubisoft with Assassin's Creed are using right now this library to create games on the web.
Yeah, and some team at Microsoft too.
Yes, some internal team that I cannot share right now.
Okay.
But,
Sorry on that.
Also using Babylon.js for some specific projects.
Yeah, cool, really cool. So Babylon is here, and it's really cool. And to use Babylon, it's pretty simple.
Yes.
I use that a lot now, and but
to use as a foundation, I can say it for Babylon.js, we wanted 2 things: simplicity and performance. I want things to be simple. I want a web developer to be able to use Babylon.js without having to deal with anything else than just what you want to create.
Yeah.
You want to create a game which is about, I don't know, birds against pigs, for instance. You don't have to deal about 3D.
And shadows.
Yeah, you just have to focus on your game, and that's it.
Yeah. So to start, just use the Babylon.js source script. It's only one file.
Only one file. You just have to reference it, and you're ready to go.
Yeah.
And then you will have to create just one specific object, the engine. The engine is your best friend. The engine is, I can say that, is the guy that will deal with WebGL for you.
Yeah.
It's the guy that will compile the shaders and also try to optimize stuff for you. You will just have to ask him, please draw me my scene, and the engine will work for you.
Okay, just a question before start some demos or something. Did you wrote the code in JavaScript or TypeScript?
That's a good question. The very first version of Babylon.js that we started 1 year and 2 months ago was created with pure plain JavaScript. At that time, TypeScript was not enough ready to be used. But we changed our mind some months ago, I think it's 4 months ago, and we backport everything from JavaScript to TypeScript. So right now, all the engine is built using TypeScript. Obviously, at the end, the output is always Babylon.js. It's a JavaScript file.
But readable JavaScript.
Yes, but all the development team is working on using TypeScript.
And what are the benefit for you?
The very first benefit was we found so many bugs. That's just amazing. We can use using a strongly typed environment is extremely powerful, because we can find bugs like calling a function instead of a member or things like that. That's pretty easy with TypeScript. TypeScript is also a great tool to work together, because you can easily integrate a code done by another people. The compilation, the static compilation, will help you find out if there is an issue or not. And at the end, because it's pure JavaScript that it's split out, that's okay.
Perfect. So now we have an engine on Babylon, and if we look at the slide, the next one.
Yeah, and if you want to work with that, you will have what we call a scene graph. So something less abstract than buffers or stuff that I present before, I mentioned before with WebGL. You will have to work with scene, camera, light, sphere. That's easy to understand. Even if you don't know Babylon.js, here you can understand that there will be a camera with a light and a sphere somewhere.
Exactly.
And the render loop itself will be handled for you. So engine.render loop will try to call your code as fast as possible.
Okay.
You don't have to...
you don't cap it. You don't limit the...
No, it
FPS.
will be handled for you by Babylon.js, freely.
Okay. So, let's continue.
Yeah.
In terms of features, I saw many features in Babylon.
I spend
amazing.
all my time working with Babylon.js. All my spare time is dedicating to working with Babylon.js. So obviously, we have a lot of features from collision engine to physics engine, a lot of stuff like support for Oculus, WebGL, shadows, whatever. We try to give you a tool that allows you to create what you want without having to think about, I need this specific stuff, and it will be. It's not available into the engine. Okay, so we try to provide you everything required. Okay,
lot of features, amazing features, and some main primitives.
Yeah, out of the box, you will be able to have some specific basic primitives like the obvious one. Box, sphere, torus, cylinder, the knot. I love the knot. It's a beautiful one. Perhaps I can show you a small demo if you
I think it's time to a demo. Yes.
So let me open a specific website I have here, ready for you guys. And I have the very first demo. So from scratch, if I want to use Babylon.js, the only thing I have to do is referencing
Babylon.
That's it. No need for other dependency. You just need that.
You provide a debug version.
Yes, there is two versions. There is the minify version for
production.
For production, absolutely. And obviously, when you want to develop, you just have to say, I want the max version, which contains all the debug information. Okay. Then the only things I need, as before, because we are dealing at the end of the day with WebGL, we need a canvas where everything will be rendered. I have some style here. The goal of this style is just to have the canvas full screen. That's it. Okay. Then, first step, I get my canvas. I create my engine. Working on this specific canvas, you can have as many engines as you want, as long as each engine has a canvas. The true parameter here define I want anti-aliasing. It will be done for you freely. And how things are working, I create my scene. I can create a camera. We have tons of different cameras. This one is about an arc rotate camera. The specific camera will work around a center and will allow you to rotate around the center. Okay? That's pretty interesting when you want to present a specific object. So the user will be able to rotate around without having to deal with translation or rotation or whatever. It will be handled for you. Then the camera will handle for you all input. Touch, keyboard, mouse. That will be handled for you, no problem. I create then a light. We have 4 different types of light. This one is something we can compare to an ambient light. When you're outside, there is light everywhere. So this is a kind of what hemispheric light can produce for you. Then the well-known create sphere. Here, I don't know why I have box, but let's call it box then. It will be far simple. So I create a box. This box will have a material. So the material is something I will go back after, is related to shaders. You don't have to mess with shader. Everything here will be done for you just by this standard material. A shader will be compiled for you.
Perhaps you can see on material dots the list of the different...
This object has a lot of features for you. You can support ambient, backface culling, diffuse color, emissive color. We have a bunch of them here, specular color, whatever. Everything that you should find into your tools like 3ds Max or Blender or Maya should be there.
Yeah, amazing, pretty amazing.
So let's see the result.
Wow!
I have
amazing
my box, yes. So I'm rotating around with my mouse, but obviously because my screen supports touch, I can also rotate around and I can even zoom, pitch and zoom. You don't have to do nothing about that. Everything was done for you by just this specific line, attach control. We try to keep things simple. If a specific feature requires more than one line, then perhaps it's a fail for us. Okay? We try to do that in a simple way possible. Another example here, same structure, and this time I want to show you, so you can create a box, you can create a sphere, a plane, cylinders, torus knot, lines between points.
Okay.
Then you can play with position, for instance, if you want to move your object around, and that's pretty much it. Let me show you the result.
Okay, in something like 20 lines of codes.
Yeah, and you have...
Comparing to the WebGL first demo.
Here we have a lot of triangle, for instance, for the torus knot, which is here. And you can see that the...
What is the material you use for the...
By default, there is a white material.
Okay.
So here I didn't define the material. So Babylon.js will create one for you. As you can see, we have this kind of lightning, what we call specular, with the shadow inside it. Okay. It's free. It's already computed for you by default.
That I love in Babylon, that the by default argument.
Yeah,
if you forgot something, you obtain a result, a concrete result, and say, oh yes, I forgot the color or I forgot something.
Most of the time I try to add missing part instead of giving you an error. I prefer adding something for you, and if you want to control that, then you have obviously to go inside your code and change that.
But it's less frustrating that nothing appears in the screen, you know.
By far. Another example here. This time I have a point light. A point light is a point. So the light
is like a spot.
Yeah, it's like a sun.
Sun. Okay.
The sun. Everywhere the light will be emitted from a specific point in space. Okay.
Okay.
So you can move it around, and it can control easily the position of the light. By the way.
Okay, and the shadow.
And the shadow implied by this light is also easily understandable this way.
Okay.
So this time I also create my camera. I create 6 spheres, different spheres. I move them at different positions. I also add a plane. And this time I will play with what we call the standard material. And I want to show you different options. The very first material will be applied to sphere 1. And this time I just want a wireframe. Okay, so it won't be a plain object, it will be an object with just line. The second material is just regular diffuse color, but with transparency this time. I can control the alpha. The third one is just not a plain color, but this time a texture. I want to use this specific texture, MISC, here. Okay. I will use this texture and apply it on my sphere. Then I can also play with the position and the scaling and the offset of the texture. So this time I will move my texture a bit on the object. I can also use what we call alpha texture. So this time 3.png. Here it's transparent, around the leaves. So this texture will be applied on a sphere. And finally, I can also play with the same alpha texture, but this time I want also to disable the fact that Babylon.js will remove for you the back face. Most of the time you don't need to render the back face. But when you apply transparent material on an object, you need to go and to see through your object.
Yeah, sure.
Okay. Sure. Then I have a plane, a texture for my plane, and this time I will scale a specific texture, meaning it will be repeated a certain amount of time. Okay. And the result of these little things, as you can see, I have my very first one, the wireframe. The second one is transparent with red color. Same object, but this time I moved a bit my texture on the second one. Then I have my alpha texture here. But as you can see, we can see through. And because the backface coding is enabled, there is no backface. And the latest one is just the same story, but this time we can see the backface because I removed this option.
Okay.
You can play with the material easily. I want also to show you some specific fun things. It's not just about shaders and objects, it's also about special effects. For instance, here, I create a box, and this box will be alongside a plane, and I create a new object, a particle system.
I really love particle systems.
Me too. We can simulate so many things with particle system, like smokes, fires, and things like waters.
Voids.
Voids, absolutely. And I just have to specify, for instance, the texture used by the particle system. Who is the emitter?
Yep.
The fountain object, which is here. It's
the
a box.
Emitter.
Okay, will be the emitter. And I define the size of the emission box, the color of the particles, the size of the particle, the lifetime of the particle. We have a lot of options available for you. The gravity applied, the direction when they start, the rotation of the particles, etc., etc. We just have to call start.
And the magic happens.
And the magic happens. Let's see that.
Okay.
That's it.
That's a fountain.
Yeah.
Particle fountain. Okay. Pretty cool.
As you can see, the color of the particle is between yellow and red because I defined two colors, and they are rendered all around the emitter, which is the box. And the box is rotating, as you can see that the particles are following the box itself.
Yeah.
You can do whatever you want with particles. That's pretty powerful. I also want to show you something different. Because here is more about web developers, and to be honest with you, if you want to create a game, you also have to work with 3D assets tools like 3ds Max or Blender. We decided with Babylon.js to support Blender 3D and 3ds Max in a really convenient way. I asked Michel Rousseau, my friend, to create for me a complete 3ds Max scene. This engine is a real engine and is fully animated into 3ds Max.
Wow. Lot of job.
Yeah, but this guy is a magician. I don't know how he can do that, but
he don't sleep, in fact.
I don't know. I think it's about talent. I wanted to allow all 3ds Max users to be able to work this way. They create all their assets, all their scene into their favorite tool, and at the end, they can emit, they can export a specific scene, and this scene can be easily loaded into Babylon.js.
So you wrote an importer for
Exactly. There is an exporter right there. You just have to say, hey, I want to put this object on my desktop. That's perfect. Let's call it engine. I want to copy the texture alongside the object itself. The .babylon format is just pure JSON.
Okay.
So it's pretty easy to use. And I just have to click export and run. And I have some kind of log here if I want to understand what's happening. And at the end, 3ds Max will call for me my favorite browser. Obviously, it's IE here. Yeah. And look at that perfectly running engine with shadows, animation, was exported directly from 3ds Max. So if you want to understand how this kind of engine is working, there are explosions. Yeah, there are explosions that move the pistons here and rotate that stuff, and that's cool.
The chain.
And it's pure WebGL code. Obviously, it's easy to use right now because you can create your scene with 3ds Max or Blender 3D and just play with it into your own JavaScript code.
Okay.
If you want to play with this kind of stuff, no, that's not the right one. Sorry about that. I'm looking for the right object. Yeah, this one. You still have to create your canvas, create your scene, your engine, create your scene, and we have a tool called Babylon.seedloader.
Yep.
And we have two different ways. You can import mesh from a specific .babylon file into existing scene.
Okay.
Okay, so let's see the result.
Okay.
Okay, I imported this skull into my scene.
For the Halloween period?
Yeah, that's exactly for that. And I can zoom in. It's me. I use Kinect to scan my... I have no noise. no noise, as you can see. Or you can obviously load a complete scene. So for instance, I have a folder here.
With scenes?
With a scene inside. Let me show you the content. I have a lot of textures, okay? And I have this split.babylon file. But I have to say something. We can use the pure JSON version of the Babylon format, but we can also use what we call the incremental version. In this case, all the scene won't be loaded at once, but we will load as soon as an object will be available to be rendered, we will load this specific object. That's pretty interesting because if you have a huge scene, you don't want to load everything in
wait
a long time. You want to load where you are and then load while you are wandering around.
That makes a lot of sense. Yeah.
So in this case, if I go back to my code here, I just use the load. I specify the folder where is the content. Here is the incremental.babylon object. And when everything is ready, I just have to say, okay, when the new scene is ready, execute when ready, just launch the render loop. That's it. All the code is here.
Yeah.
And with this code and nothing more, we just be able to do that. So as you can see, this is interesting. It's not a bug, absolutely. It's a feature of Babylon.js. We can save data locally into your IndexedDB storage. So next time you will load this in, instead of loading everything from the web, we can use the local IndexedDB. So let's say yes, obviously.
Okay. Oh, I recognize this.
Yeah, this is my favorite one. So we can wander around. The scene was loaded. There is collision. I can go through the wall. I can go upstairs if I want. That's working well. And it's like 10 lines of code. I just have to load the scene created by Michel Rousseau from 3ds Max. That's pretty simple, right? Pretty convenient.
Oh, yeah. As you said.
So let's go back to slide and...
Let's back to the slide. We cover of our standard materials. I think we can go forward. Materials. Interesting subject, the inputs. So,
we have a lot of different inputs.
Yes.
The way we are thinking about that is that the camera is the way from the user, is the user into the scene. The camera is the user. So we wanted to allow the web developer to control the camera in as much possible way
of inputs.
Yeah. So for instance, if you want to control the camera with touch, then we have a camera called touch camera.
Yes.
If you want to control the camera with device orientation, like you can do on your phone by moving your phone, then it's device orientation camera. If you want to use virtual joystick, I will show you a demonstration of that.
This morning,
and then you just have to use a virtual joystick camera. If you want to use anaglyph, the different color on your glasses, and you use...
I never tested that. I will tonight.
Pretty funny. It's the cheapest way to get 3D. But by the way, I don't have my cardboard here, but we also have a cardboard camera.
I demonstrated that this morning too.
That's perfect. We support Oculus, we support WebVR in Chrome and Firefox. We support Gamepad. All things are working. Let me show you.
Okay.
It's extremely straightforward as well. Let's take this specific sample. So as before, I load my Spirit scene, the museum. And this time I want to use Oculus Camera.
Right.
Just this line of code. When load is okay, it will call this anonymous function. This anonymous function allows me to create a new Oculus Camera. I'm using the active camera of the scene just to get the position of the user. And this camera will be attached, and I say to my scene, okay, use this active camera. That's it, nothing more. And if I'm going to my web browser, look at that. I don't have my Oculus with me, obviously. I can use the mouse to simulate that. But it's easy to understand that if I have an Oculus on my head, it will work. And obviously, because it's already connected, when I move my head, it will send device orientation API to AI, for instance, here, and I can control where I'm looking. That's interesting.
And how do you go forward?
We have two different Oculus Camera. The very first one is Oculus Camera itself, which I'm using right now, and I can use my keyboard.
Okay.
Or we also have the Gamepad Oculus Camera.
Okay.
So you can use the Gamepad while you have the Oculus on your head.
Okay.
If you want to use different camera, this is always the same story. This time I'm using virtual joystick that you showcased this morning, or I can use the Gamepad camera if I want. That's pretty simple. We just have to do that.
Yeah.
A latest point I want to mention with you guys. If you want to learn more about Babylon.js, you can obviously go to babylon.js.com site, and here you can find a Try It button. This will drive you to what what we call the playground. The playground is a place where you can experiment and learn Babylon.js with just your browser. You don't need anything else, just the browser itself. So we have different basic scene here. You can see this one, for instance. I can play with this scene. For instance, I can see here that my sphere is too much defined. I can change the sphere here. And I want to change, for instance, the number of segments and use 32. Just hit run. And as you can see, the sphere is
It's more polished.
It's more, smooth. The funny and interesting thing is that we add IntelliSense into this specific playground.
Okay.
So if you want to learn, the best way is to type. For instance, what can I do with my sphere? Sphere, dot, and automatically a complete IntelliSense system will appear. And for instance, I can say, oh, that's interesting. Perhaps I can play with position. Yes, there is a position which is Babylon.vector3 here. Let's use it. Dot, what I have a lot of operation available on the position itself. And I can see that I have X, Y, Z. So I can say X is equal to 5, for instance. And I can run that again. And that's pretty interesting because, because I still touch the sphere position right after. That's interesting.
Okay.
Let's move that here, just to be sure.
After, yeah.
Okay, and we can see the sphere moved.
Yeah.
Interesting thing, you're pretty happy with that. You're so proud of what you did. You can save it, and I will generate for you here a unique URL so you can share that with your friend.
Look.
Look what I did.
Yeah.
Isn't that excellent? And if you want to use this specific code into your own application, you can get a zip of everything required. So I generate a zip, and if you open it, you have all the code available. So you can just copy-paste that into your application. Everything is already configured for you.
In a Cordova application, for example?
For instance, you just have to drag and drop that into a Cordova application.
Yeah. Okay. We plan to have another demo about universal apps.
Yes.
I think it's time.
And it's a good time to do that. Universal app is like you mentioned with Cordova. It's just drag and drop. Let me show you that. I have here my object, a already prepared Visual Studio project. So it's a basic universal app, nothing special. I just drag and drop into the shared folder the SPLit demo we just seen, okay, Babylon.js, and obviously always my same code I mentioned before with the load. I attach my camera, and that's it. If I execute that, it will compile for me a Windows 8.1 and a Windows Phone 8.1, and that works perfectly well. Thanks to JavaScript support into a universal app, I can play with that, and then if I have some settings here, I can add whatever I want. I can change the control, for instance, by controlling that perhaps with a gamepad or with touch if I want to control that with touch. It's a full JavaScript application, but it's also a full Windows 8.1 and Windows Phone 8.1. It works exactly the same way with Cordova. We just have to drag and drop.
Yes.
That's it. It's pure JavaScript, nothing else, nothing special, no dependencies.
Okay, it's pretty amazing, and the performance are here. Definitely, the performance are here. We are in the browser. We are not native C++.
Yep.
We are in the browser with JavaScript, and you see the performance. So the last section of this talk, it's about performance consideration, because you did an amazing work based on pretty simple ideas, but brilliant one.
Thank you.
Okay, so. State caching, garbage collector, smart shaders?
Yes, we have a lot of performance stuff into Babylon.js, to be honest with you. But mainly, we did 3 big things. And I want to share that with you guys just to let you understand how things are going under the hood. And this may explain why, for instance, if you have a Windows Phone, you can go to babylon.js.com. You can try to open the SPLit scene, and it will work. It will work on your phone, because we did so many stuff around optimization. So let me explain you what we did. First of all, no, I'm not on the right side. Yeah. First of all, here is the code.
Yeah, on the slide.
On the slide, yep. Here is the code we use to multiply 2 matrices.
Wow.
Yeah, that's a big bunch of code.
Yeah.
There is no loop. I try to be the more optimal possible. And there is nothing special to optimize. We need to do all this operation.
Yeah.
But the main problem was the very first line. If you look at the code, you will see that the first line is about creating a matrix.
Yep.
Each time I multiply a matrix A by a matrix B, I have to create a matrix C that will hold the result.
Yeah.
Sure.
So you create an amazing number of metrics.
Absolutely. If you are speaking, for instance, about SPLit demonstration we just seen, because of the collision engine, because of all the operation we have to move object around, it's around 6,000 matrices multiplication per frame, and we have to do that 60 times per second.
Wow.
Yeah, that's a lot of matrix multiplication. That means that's a lot of matrix instantiation.
Yep.
And by just changing a little bit what we are doing with this specific one, so this time it's not about creating a new matrix each time, but changing a bit the API. That's less easy to read, I have to admit, because if you want to multiply A by B, you have to provide C, which is
the result.
But in this case, you create C just one time per frame, for instance, and all the matrix operation we have to do will return the result into C. So you don't have to instantiate a matrix each time. And a matrix is 16 floats, which is big.
Yes.
Yeah. What we did also, so we did that for all math operation we have. Then we also create a different array. The array in JavaScript, there is
friendly array.
Yeah, we call it the GC friendly array, garbage collector friendly array. This array is a simple array where we control the length. We control the length of the array. Meaning, if you want to reset your array, before I have to create a new array.
Yep.
There is no other option.
In JavaScript, yeah.
So each time I need an array, I have to create a new one, fill it, and just throw it away and let the garbage collector work with that. Right now, I can reuse my array, my memory, and I just have to say length is equal to 0. I control that.
Okay.
And I can reuse my memory. It's just about reusing memory. With all this operation, we obtain such good result because mostly on low-end devices, the performance was drawn by the garbage collector trying to work simultaneously with the main JavaScript itself. So if you see the slide here, you can see that before, most of the time, scripting and garbage collectors are working almost together. So if you just have one processor and one thread, that's not good.
That's a conflict. Yeah.
After that, because there is no more instantiation, it's just pure, all the power was available for the JavaScript itself.
Okay? No more for the garbage collector.
Yep.
Okay.
Then state catching is another issue we had. WebGL is a state machine, so each time you want to change something, it's extremely expensive because the state machine has just one state.
Okay.
So if you want to change something, you have to finish what you are working on, wait for the end of what you are working on, change the state, and run the next step. Rendering a new frame or whatever. So let's imagine you have two objects. The first one is transparent, the second one is not transparent. If you want to do that, you have to set WebGL to transparent mode in a way, render the first object, then change the state to not transparent, and render the second object. That's okay because you just have two objects. Let's imagine right now you have 10,000 objects. Some are transparent, some are not. We need to control state changing because it's so expensive. So we have a lot of stuff into Babylon.js about catching the state. So we try to gather objects between which share the same states, for instance, and we change the state only when required, not just when we think it should be available. Okay? And finally, last but not least, we also work on a
smart shader.
The smart shader is inside the standard material we just seen before. The smart shader is a tool we build, and I'm writing a chapter of a book about this specific technology. This book will be available through some guys at Kronos Group. The book will be called WebGL Insight, and I'm talking about this specific technology we developed for Babylon.js. In a way, it's a way to remove all the loop and all the condition into your shaders. GPU are extremely powerful to render a lot of stuff. They are extremely powerful to use single instruction, multiple data. That's perfect for that. They hate conditions because conditions can break the pipeline.
Okay,
because
it's a performance killer.
Yeah, it's a performance killer. There is no really branchment condition we have like in CPU. So each time there is an if or each time there is a loop, it could be really painful for the GPU to handle that. And most of the time, the if can break the pipeline, the current pipeline. So the GPU has to render everything, wait, and then test your value and do everything else. So what we did with the smart shader, we just think about using the dynamic compilation of shader to generate only what you need. For instance, you want just diffuse color and no emissive. Instead of having a shader with if diffuse color, then do something, if emissive, then do something, we remove physically from the shader itself the code not required. So with the smart shader technology, there is no if into our shaders.
Okay.
So it's far powerful, mainly obviously same story on low-end devices.
Okay, pretty good stuff.
Yeah,
amazing.
That's not easy to explain. I'm sorry about that.
Sure.
But
I think the people watching us understand the main gesture about the performance, and you can test by yourself the performance of Babylon with the website you describe. So. Yeah,
and if you're really interested into that, just ping me on my Twitter @DeltaCoche, and I would love to share that with you guys.
So the main purpose here is to minimize the number of active objects, like we saw in the slide, and maximize the GPU work. That makes sense.
That's the point. The CPU is the limitation most of the time, and we need to try to move the amount of work from the CPU to the GPU, right?
Yeah.
And we do that by trying, for instance, if we are thinking about particles, the very first version was just purely CPU. We moved a lot of things to the GPU. We try to reduce the number of active objects the scene render. So for instance, we're using octree, clipping, culling, all the current state technology we can have.
Okay.
That's pretty much it.
Yeah.
That's a lot of things. That's really the best way for you guys, perhaps the best call to action for you is just go to Babylon.js.com. It's free. It's based on Apache 2.
Yep. It's an open source.
Fork it. Try to do what you want to do. Ping me if you need something. We have a pretty decent forum with a lot of people that can answer a question. Yep. It's up to you.
Yeah. That concludes this part of the session, and in fact, it was the last session of the day. So we have here a little wrap-up with you. So today was an intensive day, and we learned a lot of things. I hope you learned a lot of things. From the web to the app, we start with Olivier this morning. After you have a talk with Olivier about what is what.
What is what, absolutely.
And the feeling of this solution and what you can do with that. We have also a demonstration with one of the PM of the group who built the multi-device hybrid app extension for Visual Studio. A pretty good integration of Cordova in Visual Studio. I love it very much. We have an interesting chat, I think, about the JavaScript compatibility, but the world is not pink, as we said in France. So sometimes we have some issue, and we try to resolve it with the shim a lot of issue of the security model we have. We have a nice talk with the guy from Win.js. Look twice about Win.js. It's a very interesting framework. It's not only Windows. It's very, very cross-platform.
Yep.
And we have some tests about amazing links contain thousands of items, and the performance is definitely here. Pretty good job. And we finish, last but not least, about Web3D, because Web3D it's the new web for us.
Oh yeah, that's the next frontier.
Exactly. And now we have the devices, we have the performance in our devices permit us to use the 3D. So let's go for it. Last, join the MVA community. It's a free online learning tools for IT Pro today for developers. More than 2 million registered users. And today, with this code, Crossplat Dev VS, you have a voucher to earn 50 MVA points. So let's do for that.
Don't forget the chat, and there is a poll right now. It will be quickly. There will be quickly a poll. Sorry about that. That's the end of the day.
It's important for us to understand what is missing in this kind of day, how we can improve ourselves.
Sure.
What do you want to see more in detail, more explanation, more demo, these kind of things. Over all that, all the day was about open source framework, and open source is working if you contribute, if you ask, if you give some feedback. It's true for Babylon, it's true for Cordova, so don't hesitate. Send an email, go on the forum, go on GitHub, ask for question
really
and feedback. I'm trying to do that, that's not working. Developer here, we are inside Microsoft, developer here really love this kind of feedback. I was very surprised about that when I arrived from France. I have some meeting with developers. I was timid, I was shy to ask the guy, oh, my code is not working, I don't understand well. And when the guy say, oh yes, I totally understand, I will change the code for you. It's pretty amazing. That's the way the open source is working. So don't hesitate to share your feedback. That finish your day.
Thank you.
Hope you enjoy it, and see you soon.
Bye-bye, guys.
Bye.